Hi everyone, in this video I am talking about graphical behavior of first order derivative and second order derivative. So let's start. So basically I am talking about derivative, and not only derivative but behavior of graph according to derivative. Now the thing is, firstly there is first order derivative. First order derivative, basically its notation is like that: dy by dx, and in some books it is also represented as y dash. And okay, so now the other one is very trivial, that is second order derivative. So obviously it is not, its notation is like d square y by dx square, or y double dash. Okay, now I am talking about behavior of y dash and y double dash graphically. Initially I talking about firstly y double dash, that is first order derivative. So first case is, if our y dash is greater than 0, means whenever my first order derivative is greater than 0, their graph from left to right hand side is always going to increase. For example, suppose this one is a graph. If I am observing that this graph from left to right hand side, it's going to be increasing, so it means their first order derivative is always positive. Positive means greater than 0. So second case is, when our graph suppose like that. Now this graph is clearly, if I'm going from left hand side to right hand side, this graph is going to be decreasing. From left to right hand side, its graph is decreasing. So obviously it means their y dash, means first order derivative, is less than 0. It represent dy by dx is less than 0, that is negative. I hope it is very clear. If our first order derivative is 0, it means their graph is always going to increasing. If our derivative is less than 0, first order derivative, then that graph is going to be decreasing. Okay, so now I am talking about very important double derivative, that is called second order derivative. So what is the behavior of that? Okay, I am talking about, for example, it is x and y, and suppose I make a curve like that, this one. Okay, if I am talking about only double derivative, that is second order derivative, it's greater than 0 means it's always from concave upward. Graph always formed concave upward. See here, it's always concave upward. I'm not talking about from left to right hand side, I'm talking about curve. Curve is clearly, you can say, upward side. In another words, in layman language, if I am suppose try to assume, suppose this is a water. Whenever water hit this, my graph, and it's type of a bowl, it's a type of bowl. Some of water is remain here due to their curveness, so it means it is greater than 0. Similarly, if I am talking about if when our y double dash, that is second order derivative, is 0, then their graph will be look like that, like see. Okay, and suppose again in this case, if I if there is a water, so clearly no water, any single drop stay on this yellow drop due to gravity, it's fall to down. It means it is it's basically called, that type of curve is called, this one is called concave downward, concave downward. Okay, so I hope you are able to understand. Okay, let's recall again. If my first order derivative is greater than 0, it means it's going from left hand to right hand side increasing. Similarly, if it is negative, it's going to be decrease. And double derivative is completely different. It's not talking about going to increasing or decreasing, it's talking about curveness. If my second order derivative is greater than 0, it means that it is concave upward in the sense, if suppose this uh, this color is represent water, and due to this curveness, some of water stay here due to curve, and rest of the water will drop, but some water stay here. So it's basically mnemonic to remember this thing. So basically it is called double derivative greater than 0, that is concave upward, and less than 0 case is just opposite of above. If I drop some water, no any single water stay on this curve, it's fall to the bottom due to gravity. So it's just imagination thinking to remember our curve is upward or downward. So that's it. I hope you like my video. Thank you very much.